Hello, everyone. Welcome. Thanks for joining our class today, our diagnostic training session. Now, if you have any questions, if you're joining us on Zoom, if you look at the top or the bottom of your screen, wherever your Zoom controls are, just find that Q&A button, click on Q&A. It'll open a new box. You can type in your question, hit submit, and I'll get to those questions at the end. If you're joining us on YouTube, just feel free to use the live chat function in there underneath or beside the video or wherever it happens to be on whatever device you're using. And I'll get to those questions as we go as well. So my name is Jason Gabrinas, one of Snap-on's national diagnostic technical trainers. Been in the training department the last 8 years, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I was, over time, I guess, became a diagnostic tech at the Subaru dealership. I always seemed to end up with those drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird problems that would show up. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So that's enough about me. We're here to talk about something else. We're here to talk about EVAP Systems. Now, this is our component testing series we're continuing, and we're talking about EVAP Systems tonight, and this is part one of a two-part series. So we have this week and next week we're going to talk about it. There's just so much information in there that we're trying to get into that 35, 40 minutes we try to do. So it's a lot of information. EVAP is probably still one of the most common codes you're going to find out there because there's a wealth of problems that can be had with an EVAP system. There's a bunch of different ways to go about attacking that and diagnosing it and testing it. And hopefully you'll get a few tips between this week and next week how we're going to work on it. So first off, let's talk about the beginning. Let's talk about the overview of the system. Why do we have EVAP and how does it work? So EVAP, right? Back in the day, when were these EVAP systems first put on a car? Well, you may or may not be surprised to know that EVAP's been on a car for over 50 years. 1971 was when it was mandated for passenger cars. And then 1977 is when it came off for light trucks. So you may have remember, go to a car show, see one of those early 70s, maybe even the late 60s, they might have had some on there, but you see that looks like a black coffee can on the side of the fender. Well, that's a really early EVAP system. So what is EVAP system and what does an EVAP system do? Hasn't really changed a whole lot since then. What it does is it has activated charcoal inside this canister, and it will collect the evaporative emissions, the evaporative gases off of the evaporating fuel, right? So as the gasoline evaporates, gets into the air, that's a lot of hydrocarbons in that, causes pollution. So to solve that problem, we're going to use that carbon canister to collect it. So how does it do that? Well, we have a few animations we can walk through here. So first off, let's talk about the gassing of the gas, right? So the evaporative emissions come off and it gets collected in this container, right? The container's got that activated charcoal in there. And then it allows the fresh air out. And then using the vacuum of the engine, once it is fully warmed up, it opens up this vent purge valve, and then it sucks in outside air, which displaces the EVAP gases that are in there, goes back into the engine and is reburned inside the engine, right? Extra hydrocarbons makes it nice and easy to burn because we're burning hydrocarbons to begin with. So that's the basic of how it works. It worked okay for a while, the vacuum operated systems. The problem is it's not really all that repeatable, right? So maybe I have some vacuum fluctuation with a car. Maybe I have a vacuum leak. Maybe I put a performance cam in that car and now the vacuum profile is a lot different, right? So having that being a problem, the government decided, well, let's get rid of the vacuum requirement and let's go to electronic controls, right? So that's really what we're dealing with nowadays. And if we think about it, there in this system, there's a front door and there's a back door there. So the front door is going to be that purge solenoid, and the back door is going to be what we call the vent solenoid. There's also a pressure, fuel tank pressure sensor there. And of course, the ECM controls all of this, right? So let's see how that works. So in order to put fuel in the tank, we need to make sure that the back door is open, right? We need to be able to allow all the air that's in here to escape in order to fill this with our EVAP vapors, right? So we're going to fill the tank. We're going to put a little bit of gas in there. And as we see, it must displace that air. So it goes in. It's going to push all that fresh air out the back, out the vent. And then it will fill in with the EVAP gases, right? The EVAP gases. Now, the first thing we've got to make sure is that vent valve works, right? So if I ever have a problem filling the tank, we want to make sure there isn't a blockage there, because oftentimes there can be a blockage. We'll talk a little bit more in detail about that next week, but you want to make sure there isn't a blockage. You want to make sure it's open. All right, so once we fill the tank is full, all my EVAP vapors are collected in the canister, then we still want to leave that back door open because we need to be able to draw in fresh air in order to purge. So once the vehicle's warmed up and it's in closed loop, ECM sends a signal, says open that purge valve. It's going to suck in that outside air, which is going to displace the EVAP gases, which go back into the engine, and it gets reburned, right? So that is how we recycle and reburn these EVAP gases. Now, this can also be used to check for leaks, right? So we have these two electrical switches, solenoids, and we can also draw a little bit of vacuum on the engine. You see, as it's running, as it's pulling here, we do get a little bit of vacuum coming out of the tank. But what we'll do is we'll close the vent valve, electronically close that vent valve, right? So now it's closed. So now the engine running can pull a vacuum on the system. So it'll pull that vacuum on the system, and then it will close the front door as well. So then it closes the purge valve. So now I have a vacuum on the system. My purge valve is closed. My vent valve is closed. So now a timer starts. So if we watch that stopwatch there, you're going to see it's going to count down. Based on how long it takes that vacuum to decay, if it decays, which it probably is going to, because every system has at least a little bit of a leak. But judging on how fast that vacuum decays, it will then, the computer can then calculate, okay, well, this is how big the leak is on the vehicle, and is it bigger than I want it to be? If it is too big, then it throws a code. If it's not too big, then it just says, don't worry about it, leaves it alone. So in this case, my vacuum didn't decay at all. I went through, looks like 20 seconds or so, and let's say that's the amount of time the computer wanted to wait. So in that case, it would be good. How about this time though? We'll do this again, and we'll clock that time, and you can see how the vacuum is slowly decaying there. So depending on how long it takes for that vacuum to decay, turns into even maybe a slight little bit of pressure in there because of the atmosphere. But it will pull the, get rid of that vacuum. And if it decays enough, fast enough, then the computer will know, well, this has a leak X size, and then that will throw a code, or it won't throw a code, depending on the car and the size of the leak. We'll talk a little bit more about that. So that leads us to codes, right? So if we have a leak of a size, we'll get a code, but we also need to discern, is it a leak or is it an electrical problem? This is where you can get messed up sometimes, because just say, oh, well, it's an EVAP problem. Well, yeah, it could be an EVAP problem that's a leak, or it could be an EVAP problem that is electrical, right? So even if I have an electrical problem, that could cause a leak too. So if my vent is open and it stays open, that's not going to allow it to keep that vacuum, right? So that could be a problem. The purge valve not sealing properly, things like that. So it could be electrical, or it could be a leak. Right now, back in the early days, we had that generalized PO440. It says it's an EVAP problem, it's some sort. But then as we've progressed, we've gotten a little bit more specific. We can quantify, is it a small leak? Is it a very small leak? Is it a gas cap leaking? It can tell whether that's the problem. Or is it an electrical problem? Do I have a problem with the purge control circuit, vent control circuit, pressure sensor circuit, right? Any of these would be circuitry codes. So you have to diagnose them accordingly, right? Sometimes techs just see, oh, it's EVAP, it's got to be a leak. And that's not always the case, because we do have these electrical components in there. So we just want to make sure we're carefully reading those code descriptions to make sure, is it a leak or is it electrical? So we'll talk really quick through leak testing. So if we think about a leak, means the We're not able to seal the system. We're not able to have that vacuum in there. So we need to be able to have a way to test for a leak. It's just, we can visually see maybe there's a giant hole in one of the lines, something of that nature. But the easiest way really to test is to have a smoke machine or an EVAP tester. All right, in this case, this is our EELD 500 Smart Smoke Automated EVAP Tester. That's able to pressurize the system to a very low pressure, but enough where it can quantify the size of the leak as well. Right. So if we think about the different sizes of a leak, so a gross leak's a big leak. Right. That's just a big old leak, and we have a problem in there somewhere. If we have a small leak, that's 40 thousandths. So that would be considered 99 and older vehicles didn't test for anything smaller than a 40 thousandths leak. If it had a 30 thousandths leak, it wouldn't throw a code at all. If it had a 39 thousandths leak, it wouldn't throw a code. But a 40 thousandths leak could throw a code. 2000 and newer, they changed the spec and said, well, now we have to have this very small leak in there. So if it's 20 thousandths, it'll throw a code. So as much as 20 thousandths, 19 thousandths, no, 20 thousandths, yes. So that's 2000 and newer. And there's been talk around for a while, and I think Chrysler may even have implemented some of this a little while ago, is 10 thousandths. Right? If I have a 10 thousandths leak, I will have a code at that point. And, it could go all the way down to 0. I want to have 0 leaks. And this is what the spec is. The spec is 0.00. Haven't quite gotten there yet, but we want to be able to, it's helpful to be able to quantify the leak. And that's how that EVAP tester helps us with a digital readout. What we want to do is we want to be able to put the smoke in there and then see where's it coming out, right? Here's an example of a vent valve. Vent valve is not closing all the way, and we can see the smoke coming out the back. Now, talking about the vent valve and smoke and leak testing. In order to test the system, we need to be able to close the vent valve because the oftentimes the purge valve is normally closed, but the vent valve is normally open. So we need to be able to go in there with a functional test, and we'll talk about that when we go live on the tool. But we want to use a functional test to close off that vent valve in order to make sure none of that escapes. So if I close the vent valve and I still have smoke coming out the back of the vent valve, well, that's a problem, right? That means I have a leak there out of that vent valve, and that will cause a code. How about this? This is a dual-walled fuel tank. Can I see the leak? I don't really see anything obvious, and actually I don't see any smoke coming out of it either. But metal can be porous, especially when it's rusty like that. So in the die, we also have a UV component in there as well. So the UV dye can show us where's the leak. Between this and this makes it a little more obvious where the leak might be, and that could cause a code right there. Leaking between that dual wall on that fuel tank, right? Or dual walled filler neck, right? Dual walled filler neck could leak as well. Here's another example. This was at a tech school, and they put in this, it's a fuel sending unit, and it's just one of those things with a ring, right? And they cross-threaded the ring. Couldn't find a leak, couldn't find a leak, couldn't find a leak. Finally, they put smoke in there, and then smoke's come pouring out of that ring because it was cross-threaded and it wasn't sealing properly. So you might be able to miss that because visually outside of the smoke, you might not even be able to tell that it's cross-threaded, right? It's on top of the gas tank. So just another way that smoke helped out, right? And here's just another example. Is a canister right here underneath the vehicle, and we got a split hose right there. You can see it split down there as well, a little dry rot. But we can see smoke just billowing out there. So that would definitely be an EVAP leaking problem as well, right? So leaks are a little more straightforward, especially when you have the right tooling for the job. Those are a little more straightforward. But when it comes to component failure, that's where we're going to need to spend a little bit more time on component failure. Think about circuitry and actually testing the components. So when we talk about EVAP components, we already saw a lot of those on that screen earlier, right? So we have the purge solenoid, right? That's our front door, and the vent valve, which is that back door, the vent to canister. And then of course we have the canister itself, fuel tank pressure sensor, which helps us detect leaks. And then now, especially on more modern vehicles, there's pumps and other associated modules to help us diagnose these EVAP problems as well, such as Chrysler's NVLD and ESIM, which stands for Natural Vacuum Leak Detection, and EVAP System Integrity Module is two different modules. That's NVLD is kind of the older style, and eSIM is the newer. And then if BMW, DMTL, Toyota's got one, Subaru's got one. There's a lot of different ways that they test these systems now, and you need to be able to override those. We're going to talk more about that next week. I just want to make you aware that, hey, these are components and these are parts that could have a problem or it could leak on the vehicle as well. So we just want to keep that in mind. So today we're going to talk about the purge solenoid. So there's just a simple diagram of a EVAP system. We got the fuel tank over here, fuel filler neck, fuel tank pressure sensor, and then we have the line comes out for the EVAP gases, goes to the canister. We got the vent solenoid down here, and then we also have the purge solenoid up there, which then goes and vents into the engine, right? So the purge solenoid is the last stop before the engine. Usually it's in the engine compartment. It could be mounted right on the intake manifold, something of that nature. Every vehicle is different, of course, but they all work in a fairly similar fashion, right? So usually, by and large, it's going to be a pulse width modulation controlled solenoid. So the computer is going to modulate the voltage going to the solenoid to keep it open a certain amount. It can be open. Usually it's in a percentage range, right? It can go from 10% up to 60% or even 100%, depending on the vehicle. So it allows it to open a certain range to control the flow of the vapors. So it allows those EVAP vapors out of the canister, draws them out, and allows them to be reburned in the engine. Then, as we saw in the animation earlier as well, it's also used for leak testing. So I can draw the vacuum through that purge solenoid, then I close the purge solenoid, and it allows me to do that vacuum test as well. So used for multiple applications. They're usually pretty simple. It's 2 wires generally, and we're going to walk through a case study on how we had a problem with that, and we figured it out, right? So this is on a 2011 Ram 1500. It's got an EVAP problem. So the customer complains the engine light's off, and vehicle had already been in 2 weeks prior to the same shop with EVAP codes before. Now, those prior codes 2 weeks before, they were traced to a leaking hard line in the engine compartment. Also had a couple of other issues in the back of the EVAP systems underneath. But is this a comeback or not? This leads me back to what I was talking about before. Is it a leak or is it a circuit problem? So we pull the codes, and sure enough, EVAP purge 1 control circuit. So right there, it tells me, well, I don't have a leak. I'm not needing to chase another leak on this vehicle that already got chased a couple weeks ago. It is a problem with the purge solenoid control circuit. All right, so this is on a Zeus. So on the Zeus, we have Intelligent Diagnostics. We can just click on that diagnose button right there, and it brings me to my landing page. Now, it looks like we don't have any TSBs. That's good, so I don't have to bother wasting time looking those up. Next thing, we have top repairs. So top repairs, based on however many repairs we have on this vehicle, is replace the EVAP purge solenoid valves. Pretty common. Not the highest by mileage, depending on where your mileage is at. Sometimes it's the PCM. Maybe you just want to reprogram that, actually. But sometimes I guess you do have to replace that. And so on and so forth. EVAP leak detection unit, and replace the connector as well. So a few repairs there. EVAP purge solenoid valve looks overwhelmingly like the one, but we can't be 100% sure yet. Let's walk through and learn a little bit more about this code and a little bit about this system. So we're going to scroll all the way to the bottom, and we're going to go to our direct link to repair information. So if you have one of these tools and you have ShopKey or Mitchell, this will give you a direct link to that repair information right from the tool, never have to leave the fender of the vehicle. So if I click on that, it's going to pass the vehicle through. It's going to pass the code through as well, and then I can get to my information. So let's go to operation, and it gives us a set condition. So the powertrain control module will set a trouble code if the actual state of the solenoid does not match the intended state. It's a 1-trip fault and 3 good trips to turn off the light. So that means the PCM will tell the solenoid to do something, and it also has a return line, so it can monitor that and say, well, did it do what I told it I wanted it to do? I told it to open 50%. Did it open 50%? And it uses voltage to do so. All right, so it looks like we're going to be testing it in a couple ways. Let's look at the wiring diagram real quick as well. This is the factory one from Chrysler. We have the powertrain control module here. EVAP purge control goes out to one side, and then the other side, that's that return line, gives me my purge solenoid signal on the back end. So this is, I'm going to send out a pulse width modulated signal, and it's going to tell me what is it doing on the way back. So we go into functional tests, and we see we have a proportional purge solenoid test right there. You can click on that, and it brings us to this page. So we have a place where we can go up and down percentage-wise. It's going to give us our pulse width modulation. In this case, the engine's not running. We're just going to do a functional test with the key on, engine off, and we're going to see what it does. But first, I want to be able to monitor that line as well. I want to be able to monitor and see what's the computer doing, and I want to be able to see what's coming out the back end of the solenoid. So we'll go into guided component test. Under guided component test, and we go to the component information here. It says PCM does not energize the solenoid during cold start warm-up period and the hot start time delay. When de-energized, no vapors are purged, so it is not purging until the computer tells it to. PCM de-energizes the solenoid during open loop. Once it's warmed up, once it enters closed loop, after it reaches a specified temperature and the time delay ends. During closed loop operation, the PCM energizes and de-energizes the solenoid for 5 or 10 times per second. That's that pulse width modulation, depending on operating conditions. PCM varies the vapor flow rate by changing the solenoid pulse width. More pulse width opens further, less pulse width opens not as far. Pulse width is the amount of time the solenoid energizes. PCM adjusts solenoid pulse width based on engine operating conditions. We can see we have our connector view, and pin 1 is the control side. Pin 2 is the return side, so that's our signal back to the computer. Solenoid is really easy to get to. Actually, it's mounted right next to the battery, left side of the engine compartment, wide open right there, real easy to get to. So the best place to test it is going to be at the solenoid itself. So we're going to pull up. First thing we're going to do is a pulse width test. So this tells us our percentage of pulse width that is being output by the computer right now. So I'm going to pull up the scope on one side, have my scanner on the other side. Right now I'm pushing 50%. So I should see 50% over here. And it looks like we're at about 48.5%. It's close. Not quite where I want it to be, though. At 60%, we see it's a little below. At 70%, we see it's a little below as well. So that's a little odd, mysterious, something to look into, I guess. So that is our pulse width. That's checking the signal side. Let's check the return side and what we should expect to see as well. We should expect to see a voltage, right? So I'm at 20% and I see 1/10 of a volt. All right, that seems like it might be a little low, because if I'm seeing 1/10 of a volt at 20% and 2/10 of a volt at 30%, and so on and so forth, if I get down to 10%, I'm going to see no volts, right? Because going down by 1/10 of a volt every time I get down there. So that's my return voltage. Now the engine's not running, so the voltage would be different if the engine was running. But in this case, we're just seeing how the solenoid's operating. So that seems a little low if we think about it. And there's just another example at 30%. We're pushing at about 2/10. So I said, all right, well, what would drop voltage? Could be a problem in the line. Could be a problem in the solenoid itself too. If we had a resistance problem in the solenoid, could give us an issue. So we said, kind of looked up the spec, and the spec said 14 ohms or so. So we went in 14.35 ohms. Now, I don't know how sensitive this computer is, but if it is pretty sensitive, and we got 14 ohms as a spec on the high end, then 0.35 is going to go over, and it's not really going to like that if it's very sensitive. So you said, all right, so it's past the spec. It's not a lot. It's not by a lot, but it's enough. Let's get a part. Get a new part. So order a new part. Let's ohm out the new part before we put it in, right? We want to double check our new parts before we put it in to verify the problem. So the new part's 14.22 ohms. Not a huge difference between the two. It's like 0.13 ohms. But when we install it, how's it look? So we install it how it looks, 50%, we got 0.5. We bring it down to 40%, we get 0.4. We bring it down to 30%, we get 0.3, and then 0.2, and so on and so forth. So just that little itty bitty bit of resistance was enough to drop it 1/10 of a volt, and the computer really didn't like it. So I guess that computer is pretty darn sensitive to what its input voltage is. And once we replaced it with the new solenoid, it fixed the problem. Car was fixed, never came back again. So I just thought that was kind of a weird, interesting one. It's actually precipitated by, hey, this car had already been in for EVAP problems, a leak. So I don't want another leak on this thing, right? So being able to diagnose that electrical problem, figure out, is it an electrical problem or not? All right, let's go through our on tool section now. And I have my trusty 2016 Chevy Tahoe with a 5.3 liter engine in here. And we're going to walk through how we would set up. Let's test something with the component test on one side and the scanner on the other side, right? So we're going to go through, let's walk through a few things on the scanner we're going to want to talk about. And then we'll test the purge solenoid because that's what we talked about before. So we'll go in the scanner and, we could do a code scan, see what codes are in there. But in this case, I just want to go right to the solenoid and test the solenoid. So I'm going to go to my engine. And then that would be under functional tests, right? So pretty much by and large, any of the vehicles are going to be laid out the same. So we're going to go to functional tests and take a look at the tests. Now, I actually got an email about this the other day. How would I go about sealing up a system in order to do a test on it, a leak test on it? We don't want to do the EVAP service bay test. That's not going to work. So that's in a way to force the monitor while it's in the bay. What we want to do, oftentimes, if it's a solenoid, we need to go into output controls. Sometimes you can do a purge seal type thing, but other times you have to actually go in and function with the actual solenoid itself. So here's EVAP purge seal, and then EVAP vent solenoid valve as well. So I'd want to close that vent solenoid in order to seal up that system. But in this case, what do I want to do? Well, I want to test that purge solenoid, right? So I'm going to go into purge solenoid, and it's going to load into my test. It won't function if the onboard EVAP diagnostic is running. That's okay, because we're not doing that. It's going to collect data, and it's going to bring me into my functional test. All right. So it'll give us pertinent data for it. Now, of course, I'm not hooked up to a real vehicle, so we don't see real numbers here, but in a real world, you would see the numbers there. So what's going on, percentage-wise and things. But now that I have this functional test up, I want to hook up to the solenoid and see what's going on. So if I go back to my home screen and I go to my guided component test, now this will work on any Windows-based tool. The tool is not Windows-based, like it's a Triton or a Modus. You'd have to go back and forth, but you still can. I'll go into guided component tests, and I'm going to go into engine. So guided component tests, that's our database of over 5 million components. Goes back to 1981 and covers a wealth of systems. Most of the vehicles we cover are in there. So once I load into a system, so I chose engine system, we have subsystems or components in there. So I have EVAP system. Going to EVAP system, I can go into information. It's going to tell me how it works. We already just walked through about 20 minutes worth of class on how it works. So I'm going to go right to my purge solenoid here. Purge solenoid, we can do a duty cycle test, a resistance test, or a signature test. So I'm going to go into my duty cycle test. And it's going to give me based on my percentage, because I'm operating duty cycle on my scanner, right? So I want to be able to test it. It's going to give me my connector view here. So this is the purge solenoid there. I have ignition positive, so I should see voltage at A. And then the purge controls is my pulse width modulation on the other side. So that's B. So if I hit view meter, and there I see 10% going across. All right, so my meter's open. It's running. It's actually running on a graphing multimeter. And go up to meter up top. And meter one more time. It's going to give me a window. All right, so if I have a Windows-based tool, I can do that and open a window. Once I'm done there, I can go back to my scanner, go home, go scanner. There's my test. All I have to do is go down here on the bottom, pull up my taskbar, open my scope viewer, which I can put on the right. And then there's my scanner, which I can put on the left. So now I have 10%. Now this is just going to be a simulator, so it's bear with me here. But if I go up to 20%, I should see it go up to, there's 20% right there. It's on a knob. It's kind of hard to get it exact with the simulator. 20%, 30%, should see it go up to 30%, right? 40%. Right, so there's my 40%. So I want to be able to control it on the left, and I can see the output on the right, and I can see what the difference is between those. And boy, that pattern doesn't look so good, but I guess that's just my simulator today. So being able to function it on the left and see the result on the right is pretty handy. So what if I set it to 40% and I saw only 30%, or I saw nothing at all, right? So it's just not coming out at all. I'm not seeing anything. So that would definitely be a problem somewhere in the control side, because the computer is sending the signal out, So it'd be on that signal wire that goes to the sensor, right? So if I bring it back up to 40%, that's where we were. And I can cycle this one all the way up to full 100%, right? So that's all the way up there. And that'll be full 100%. Pull it down to 90, down to 90, right? Up there, right? Yeah, that's enough. There we go. All right, so that's how we can function it on the same tool on the same screen. Now, if you don't have one of these tools, the Windows-based tools, that's fine. You can still will have the functional test in there to go plus and minus. And then you just have to monitor it with a meter or a standalone scope, or just flip back and forth, depending on what you have for a tool there as well, right? So that is testing our purge control valve. We talked about how EVAP operates on a vehicle there, and how we open and close things, and the vent valve and the EVAP vent solenoid and things like that. So hopefully we got a good grounding on how our EVAP systems work. And then next week, we're going to dive in a little bit deeper on how each of the components works. We did a little bit on the purge today. We're going to talk more on the vent valve, the fuel tank pressure, and then we're going to go into the new style pumps and such that we're going to talk about next week. So that'll give us a little bit more time when we get there as well. So hopefully we'll see you next week. Let's flip over to talk about that next week. All right. So next week, we are going to do part 2 of this 2-part series on the EVAP system. So as I said, we'll be talking about those leak detection pumps and things. There's a leak detection pump right there off of Subaru, right? So there's plenty of different ways, functions on the scanner, and then also testing with my scope or component tester in order to go through this. I mean, they seem like fairly simple systems, but they're underneath the car. They can get hit with dirt and water, and I couldn't tell you how many times I had corroded connectors and things like that. So definitely worth your time, I think, to go through it and try to figure these things out. So once again, same time, same place, 6 and 9 Eastern, snapon.com/OT if you want to register to join me on Zoom, or my 6 o'clock Eastern, which I'm doing right now, goes to YouTube. So youtube.com/Snap-on Diagnostics is where you'd want to go for that. Also, make sure if you are watching on YouTube, please subscribe. Give us a thumbs up to like the video, like the stream, and make sure you hit that little bell next to the subscribe button as well, so you get a notification anytime we go live or anytime we post new stuff. If you want to see some of our past episodes as well, there's a ton of information there. We've been doing this for quite some time. We have things like ADAS, data bus, module setup, thermal imaging, and of course, all of our component testing. We see fuel pumps, O2 sensors, gasoline direct injection was last week. That one was pretty popular as well. So if you want to see any of those, there's a playlist for all of our live training up on that youtube.com/Snap-on Diagnostics as well. Okay, time for questions. But before I get to questions, I do see quite a few between YouTube and the Zoom there. But let's make sure we talk about my buddy Al. So my buddy Al does training as well. We do training 4 nights a week here at Snap-on Diagnostics, and it's all free. Go figure. So Monday, Wednesday, and Thursday, Al does scan tool training. So Monday is Apollo, Wednesday is Zeus, Thursday is Triton. So he goes through everything from let's set up your Wi-Fi, make sure that works, through let's set up your free Snap-on Cloud account, make sure we can set you up so you can share files with your customers and share screenshots and pre and post scans and things like that. And then he walks through complete code to completion on a code through Intelligent Diagnostics. How does Intelligent Diagnostics help me as a tech go through and diagnose cars quicker, faster, easier? So that's about an hour on Monday. And then on Wednesday and Thursday, he goes through that hour on the tool, and then he takes a little break. Then the second hour on the Zeus and the Triton goes through the scope, the meter, the guided component test, all the scope and meter functions of the tool with some real world examples in there as well. It's a very thorough class. Al's been with us for over 30 years. He came over with the brick, so he knows Snap-on Diagnostics like the back of his hand. So definitely a deep well of information there. Definitely worth your time to check out if you want more information on one of those tools. So let's go back to the questions. All right, let's check Zoom first. Okay, Tom, I knew you'd chime in here on a couple things because I know you work for Chrysler, right? So you said, yep, Chrysler has implemented 10,000th leak. So that's good to know. I had heard that, but I wasn't 100% sure. But from a Chrysler tech, now I know. Older Chrysler Jeeps had leak detection pumps not natural vacuum. So NVLD was also just, I guess, one of the ones that they used in there as well. So maybe, I guess, looks like they've used a few different ones. But there's been quite a few different ones. We'll talk about a few of them next week as well. Let's see. And then David asks, closed vent valve, where is the best location to connect the smoke machine? I've been putting in the purge valve line. Would that work? Yes, it absolutely would. A lot of vehicles, they'll actually have that little green cap on the purge line as well. And that will allow you to, if you take the Schrader valve out, allow you to just go right in there, smoke right in there. But yeah, purge line, definitely. That'll get you all the way back to the canister. Could even get you into the fuel tank as well, if depending on how much smoke you put in there. You also want to make sure you're smoking the other way too, because you could have a leak on the other side as well. So purge line is definitely a good place to start. If you don't find a leak, check the other way as well. Like I said, you could have a bad line or a bad valve, so you could put it right into the valve, as a matter of fact, and smoke in there as well. But yeah, absolutely, right from that purge line, be a good place to go there, Dave. Thanks. Okay, now let's check the YouTube comments. Nicholas, lots of comments there. Thank you very, very much for checking in there. Manny, good to see you. The Winton, hello. Good to see you. Let's see. We do have a question from Nick. Let's see. Questions time. No service book on BMW. What Snap-on scanner rewrite service history? Well, Snap-on scanner rewrite service history on a BMW. Yes. So you can go in there through the functions, either through regular functions through the vehicle, you're able to do that. And then also with the expert mode, you're able to go through and rewrite the service mileage intervals and things of that nature with the Snap-on scanner for sure. All right. So hopefully that answered that question. And we will be talking a little bit about BMW's DMTLs next week as well. So with that, looks like we've cleared the board there. Thank you, everybody, very much for attending. Let's get to the end here. There we go. Thank you very much for taking time out of your busy week. Come join us. Hopefully we learned a few more nuggets about EVAP, and next week we can learn even more little nuggets about EVAP and hopefully take our experience to that next level. So definitely appreciate taking your time. Enjoy the rest of your week. Enjoy your weekend. Stay safe and definitely take care. Thank you.